So here it is told that a cubical volume is bounded by the surfaces x equals to a, x equal to 0, the y-axis, or I can say it is the yz plane, x equal to a, y equal to 0 is the xz plane, y equal to 0, y equal to a, z is equal to 0, and z equal to a. Now this is z equal to 0, this one is z equal to 0, and this line is z equal to a. This plane z equal to a. Z equal to a, and then the electric field in this region is given by E equal to E naught x I cap, where E naught equal to this. E naught is 4 into 10 power 4 Newton per coulomb per meter. A equal to 2 centimeter. The charge contained in the cubical volume is Q into 10 power minus 4 coulomb. The value of Q is so here we can say that here we can epsilon naught is 9 into 10 power minus 12 coulomb square per Newton meter square. This is E naught. Now we can say that the net charge enclosed divided by epsilon naught, that is equal to integral E dot ds. It means that it is equal to the net flux through the cube, that is equal to the charge enclosed within the cube by epsilon naught. Now closed integral E dot dA, that we have to find it, which is E dot A. Now electric field varies with x. Electric field with only vary with x. Electric field is along the x in the direction of x-axis. So here the area vector is in the opposite direction. So dot. Here the area vector is towards the left and the electric field is acting towards the right. So here the phi flux for the left phase, that will be negative, and the flux for the right surface, that will be positive flux. Since y here, let's say flux is phi 2. So net flux will be 0 here. The net flux we have to find at x equal to a. Here it will be positive flux. And so here the direction of the electric field and direction of the area vector is same only. So this will be equal to E. So electric field at x equal to 0, that is 0 only, since E is equal to E naught x I cap. So this is 0 for x equal to 0. But at x equal to a, the magnitude of the electric field, that will be equal to E naught a I cap. So therefore, we can say that the net charge enclosed Q enclosed by epsilon naught, that is equal to E1 into the area, that is A square only. E1 A square. Electric field is towards the left, so this will be minus E1 A square, and here it will be plus E2 A square. Therefore, the electric field at x equal to 0 is 0, and at x equal to A, that is EA. So that will be EA into A square, that is equal to EA cube, E naught A cube. And similarly, Q enclosed, that will be equal to Q enclosed, that will be equal to epsilon naught times EA cube, E naught A cube. So epsilon naught, that is 9 into 10 power minus 12 into E naught 4 into 10 power 4 per coulomb, and A, that is 2 centimeters, so 2 into 10 power minus 2 meter into the power 3. So this much coulomb we have to find out, which is equal to so 4 9 is 36, 36 into 8 into 10 power minus 12 plus 4 plus 6 coulomb. So this will be 6 8 is 48, 3 48, 3 8 is 24, 288 into 10 power, this is minus 14 coulomb. 288 into 10 power minus 14 coulomb. So the answer is 288. Then here it is told two equal positive point charges. Two equal positive point charges are kept separated by a distance 2a. The distance of a point from the center of the line joining two charges, the distance of a point, the distance of a point, distance of a point, center of the line joining two charges on the equatorial line perpendicular bisector, at which force experienced by a discharge Q naught uh, becomes maximum is A by root x. So here the force experienced by this discharge will be maximum. Here the, so this R is A by root x, but then the value of x is how much? So at R equal to A by root x, it is told that the net force, that is maximum. Then R should be how much? A by root x. Here this will also exert repulsive force. This will also exert repulsive force by the charge on the charge Q naught. Now if I say this is theta, and this will be theta, and this will be 91 as theta, and then this will be again theta, and this will be 91 as theta. So this will be again theta. So I can say this way it will be 2q0 cos theta. Sorry, this way the force acting here, the same force will act, since why this length will be the same only, since it is it will be a r l cos theta, that is equal to a l sin theta, that is equal to r. This will be 2f cos theta. This is the repulsive force, and f sin theta and f sin theta components will get cancelled. So therefore, you can say that the net force experienced by the test charge q0, that will be equal to q0 times 2f cos theta, where f is equal to 2 q0 q by q1 q2 by r square, which is q1 q0 q by 4 pi epsilon naught, 4 pi epsilon naught. This will be L square. So r equal to L sin theta. So I can say L equal to r cosec theta. Therefore, the net force, that is equal to 2 into q0 q by 4 pi epsilon naught L square into cos theta, where cos theta, that is a by L. It is r cosec theta. The force q0 q by 2 pi epsilon naught L square, which is r square cosec square theta, into cos theta. Cos theta. From here, tan theta, I can say tan theta is equal to r by a, and from here L square, I can say it is r square plus a square. From here cos theta, I can say cos theta is equal to a by L, where L is equal to a L is equal to square root of r square plus a square. So this is coming q0 q by 2 pi epsilon naught into r by cos theta is r by a by L. So it is a by L cube. Therefore, the net force acting, it is equal to Q naught QA by 2 pi epsilon naught into L cube. L is root over r square plus a square. So it is r square plus a square whole power 3 by 2. Whole power 3 by 2. So it is a function of the net force is a function of r. So therefore, for maximum should have df by dr, that should be equal to 0. Since why here f is a function of r. D by dr of q naught qa by 2 pi epsilon naught into r square plus a square whole power 3 by 2. That is equal to 0. So therefore, this will be d by dr of 1 by r square plus a square whole power 3 by 2. That is equal to 0. So therefore, this will be d by dr of r square plus a square whole power minus 3 by 2. That is equal to 0. So therefore, I can say this will be nx power n minus 1. So minus 3 by 2 r square plus a square whole power n minus 1. So it is minus 5 by 2 into 2r. That is equal to 0. Okay, so here we have said that this it is the net force on the charge q naught, that is q naught qa by 4 pi 2 pi epsilon naught into L cube. Now L I can say a by cos theta. So therefore this I can write q naught q by 2 pi epsilon naught a square into cos cube theta, since a and a cube will cancel. So now therefore the net force that we can write, that is q naught. Okay, so it means df by d theta, that should be 0 if theta if force has to be maximum, then we can say 3 cos theta into 3 cos square theta into minus sine theta, that is equal to 0. So I can say sine theta into 1 minus sine square theta, that is 0. So it means that sine theta can't be 0, sine theta should be 1. So therefore theta should be equal to pi by 2. So now if theta is pi by 2, so then we can say the net force should be 0, and r should be equal to, here it is told, 8 tan theta, so 8 tan pi by 2, that is in infinity. So therefore infinity, that should be equal to a by root x. So root x, that is equal to a by infinity. So root x should be 0, so x should be 0. So the value of this is 0. Yeah, so here it is told expression for an electric field is given by E vector equals to 4000 x square I cap volt per meter. The electric flux of the cube of side 20 centimeter when placed in electric field as shown in figure is dash volt centimeter. So the flux phi E, that is given as E dot S dot E dot A. So electric field is acting along the x-axis only. So only the side faces will contribute to the flux. So for the left face, the area vector that is given as this is 20, so 0.2 meter into 0.2 meter. This is the area, that is 0.04 meter square. It is 4 into 10 power minus 2 meter square into minus I cap. This is, so this will be equal to E dot A for this surface, and for this surface the area vector is towards plus I cap. This is 4 into 10 power minus 2 meter square I cap. So here for this surface we will have positive flux, and for this surface we will have negative flux. But here at x equal to 0, the means on the on the yz plane, the electric field is 0. So here there will be 0 flux. So the flux that will be equal to E dot A. So 4000 into x square. Here the value of x is 0.2 meter. So 0.2 whole square into, this is 4 into 10 power minus 2. This is volt meter. This will come. So this is 4 into 10 power 3 into 4 into 10 power minus 2, and this is also 4 into 10 power minus 2 volt meter. So this will be 4 for 16, 16 for 64, 6.4 volt meter. Now 1 meter equal to 10 power 2 centimeter. So I can say this will be 640 centimeter volt centimeter. So 640 volt centimeter is the electric flux through this cube. So 640 is the answer. Now here it is told as shown in the figure, a cuboid lies in a region with electric field E equals to 2x square I cap minus 4y j cap plus 6 k cap Newton per coulomb. The magnitude of the charge within the cuboid means Q enclosed, that is equal to n epsilon naught coulomb. So then n will be how much? The dimension of the cuboid is 1 into 2 into 3 meter cube. Now for the flux on this x equal to 0, the electric field will be 0 only. The x component of the electric field will be 0 only. Uh, that side you can go. Yeah, here washroom, it is only for the staffs actually. So here y. So here z value is 0 for this surface. So at z equal to 0 also, the z component of the electric field will be 6. Z component of the electric field is 6. And for z equal to 3 also, at z equal to 3 also, for this plane, the z component of the electric field is 6. So constant electric field. So the uh, flux through this surface and through this surface, if we add phi z, that will be 0 only, since constant electric field. Here there is here the area vector will be is 1, this is 2. So 2 meter square minus k cap. And for this one, it will be 2 meter square k cap. So therefore, for this surface, if I do phi 1 z flux to this surface, that will be equal to 6 k cap means Ez into area, that is 2 meter square minus k cap. It's dot product, so that is minus 12 Newton meter square per coulomb. And for this surface, the flux phi 2 z, that will be equal to, this is actually 6, okay, 6 k cap dot product with 2 meter square k cap. So this will be 12 Newton per coulomb meter square. So these two will cancel out. So phi z, that is phi 1 z plus phi 2 z, if we add, that will be 0. So the net flux through the top surface and to the uh, uh, bottom surface, that will be 0. And phi y means to this side faces. Here actually for this one, y equal to 0, y equal to, at y equal to 0, the y component of the electric field is 0 also. And for the back surface, for here also, x equal to 0, at x equal to 0, the x component of the electric field is 0 only. So the net electric flux, that is equal to the net charge enclosed by epsilon naught. So the net flux, net electric flux, that will be equal to the flux through this front surface, which is phi 2x, plus the flux through this side, the right face, that is phi 2y, phi 2y. So this will be phi 2x. So this will be electric field at x equal to 1, at x equal to 1, Ex, that is x component of the electric field, will be 2 I cap Newton per coulomb. So this will be 2 into 2 Newton per 2 I cap dot product with dot product with this area. So this is 3 and this is 2. So 3 to the 6, 6 Newton meter square per coulomb, and plus phi 2y. So through this, that will be 2 into so this is at y equal to 2. At y equal to 2, 2 into 2 dot 2 into 6. So y at y equal to 2. So this will be 3 and this is 1. So 3 into 3 Newton meter square per coulomb. So uh, this is a 12 plus 6, that is equal to 18 Newton meter square per coulomb. So therefore this phi net, that is 18, that is equal to q enclosed by epsilon naught. So therefore the net charge enclosed in the cube, that is equal to 18 epsilon naught coulomb. So therefore the value of n will be equal to 18. N is 18. Now here it is told for a charged spherical ball, there is a charged spherical ball and this electrostatic uh, po- 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 potential inside the ball varies with r as v equal to 2ar square plus b. Here a and b are constants and r is the distance from the center. The volume charge density inside the ball is minus lambda a epsilon, where epsilon is the permittivity of the medium. So rho, that is minus lambda a epsilon naught, then lambda we have to find out. So the volume charge density rho is this. So it is obviously a constant. So volume charge density is constant. So it is so it is obviously a uniformly charged sphere. Uniformly charged, it should be an insulating sphere. Uniformly charged insulating sphere. So therefore, for an insulating sphere which is uniformly charged, the electric field, if you have to find at any point r, that is given as um, minus dv by dr, which is equal to electric field is minus dv by dr and which is also equal to kq by r square, which is q by 4 pi epsilon naught r square, and q, that is equal to rho into 4 by 3 pi r cube. So that is rho r by 3 epsilon naught. So now therefore minus dv by dr, if you do, so that will be minus 2a into 2r, that is equal to minus 4ar, and that is equal to rho r by 3 epsilon naught. So r will cancel. So therefore rho we got it as, what's here, 12. So minus 12a epsilon naught. But here we can take it as epsilon also, if instead of uh, uh, vacuum or air, some other dielectric medium is being used inside the sphere. So 12a, so it is minus 12a epsilon naught. So therefore the value of lambda is 12. Value of lambda is 12. Okay. So then here it is told that um, so here it is told that point charge q1 equal to 4q naught is placed at the origin. At the origin means at x equal to 0, q1 charge is placed, which is equal to 4q naught, and another point charge q2 is placed at x equal to 12 centimeter. So at x equal to 12 centimeter, the charge q2 has been placed, which is minus q naught. Charge of proton is q naught. The proton is placed on the x-axis so that the electrostatic force on the proton is 0. So it means the proton should be kept somewhere here, means let's say at x equal to a centimeter, at x equal to a centimeter, the charge q is placed, q is equal to q naught. So then the net force on it should be, net electrostatic force should be 0, since why this will be the force F2 and this will be F1. F1 is the force which is exerted on Q due to by Q1. And F2 is the force exerted by Q2 on Q. So here we will have the null point. So in this situation, the position of the proton from the origin is dash centimeter. So it means A, the value of A only has been asked. So F1 that will be equal to, so this length is A units and this length is obviously A minus 12 units. So therefore now here you can see that A should be more than 12. The value of A should be more than 12. So now F1 should be equal to F2, means their magnitude of these two forces should be equal and their direction is opposite and they should cancel. Then only the net force on this Q will be 0. Here we will have the null point. So F1 will be KQ naught KQ1 by A square. That should be equal to KQ2 by A minus 12 whole square. So now KQ and KQ will cancel. Therefore, I can say Q1, that is 4Q naught by A square, that is equal to Q2, that is Q naught. Means the magnitude of Q2 is Q naught by A minus 12 whole square. Now Q naught will cancel. So now if we square root on, take square root on both sides, then we will have 2 by A, that is equal to plus or minus 1 by A minus 12. So therefore I can say that plus or minus 2 into A minus 12, that is equal to A. So therefore I can say that A minus 12, that is equal to plus or minus A by 2. So now we can have that one is A by 2 equal to 12, or we can have 3A by 2, that is equal to 12. So now from here we will get A equal to 24, or here from here we will get A equals to A equals to 12 into 2 by 3, that is 3 4s are 12, 4 2s are 8. So A will be equal to 8, but A can't be 8 since here A should be more than 12. So therefore A should be 24. So therefore at 24 centimeter, if we keep the proton at 24 centimeter from the origin, if we keep the proton, then only the net force on it will be 0. So the answer is 24 centimeter. Then here it is told a uniform electric field of 10 Newton per Coulomb is created in between two parallel charge plates as shown in figure. An electron enters the field symmetrically in between the plates with a kinetic energy. So here the initial kinetic energy, which is, I can say, if it has initial velocity u, then it will be half mu square, which is equal to 0.5 electron volt. Means it is half into 0.5 means half into 6, no, 1.6 into 10 power minus 19 joule. And here the electric field is acting, which is downwards, which is 10 Newton per Coulomb. So therefore the the electric force is acting upwards, which is E into E. Since electron has got negative charge, so the force will be opposite to the direction of electric field. So E into E. So therefore the acceleration is only along the y-axis. Since along x-axis the acceleration will be 0. Since along x-axis there is no force, and along y-axis only the force, that is Fe. So Fe by m, so that will be equal to Ee by m, but m is the mass of the electron. So now therefore it is told that the length of the plate, each plate is 10 centimeter, means 0.1 meters. The angle theta of deviation of the path of the electron as it comes out of the field is in degrees. So now if this is the final velocity of the electron when it comes out of the region, comes out of the two plates, then this will be equal to v cos theta, which will be equal to vx, which will be always constant only since acceleration along x-axis is 0. So vx will be always equal to u. Vx will be equal to u only. And vy, that will be equal to ay into t. So this will be equal to v sine theta, which is equal to vy. And then t, how to find? T will be equal to L equal to v into t. So t will be equal to L by, so this is L. L is the length of the plates, length of each plate. So L by u. So therefore vy, that will be equal to v sine theta, that will be equal to E by m into t into L by u. Now therefore we can tell v sine theta by v cos theta, which is tan theta. Tan theta will be equal to vy by vx, which is equal to E by L by u mu divided by u. So this will be EEL by mu square, tan theta. So now half mu square, that is this, half mu square, that is equal to half into 1.6 into 10 power minus 19 joule. So therefore mu square, that will be obviously 1.6 into 10 power minus 19 joule. So therefore we can say that tan theta, that will be equal to EE, the charge on the electron, that is 1.6 into 10 power minus 19 into E. E is the electric field, which is 10 power, which is 10 Newton per Coulomb into 10 Newton per Coulomb into L. L is 0.1 meter, 0.1 meter divided by mu square, which is 1.6 into 10 power minus 19 joule. So therefore this will cancel and this will be equal to 1. So tan theta is 1, so theta is equal to 45 degrees. So 45 degrees is the answer. So when it comes out of the field, the angle of deviation of the electron, the path of the electron, is 45 degrees. Then here it is told that a stream of a positively charged particles having q by m, a stream of positively charged particles having net charge q by m, that is equal to 2 into 10 power 11 coulomb per kg, and velocity v naught vector, that is equal to 3 into 10 power 7 I cap meter per second. So they are taking, this is the x-axis, this one is suppose the y-axis. So therefore they will undergo some deflection in their path. So there will be some deflection in their trajectory. So the electric field that is acting along the y-axis only, since it is 1.8 kilovolt per meter j cap, or I can say it is 1800 volt per meter j cap. Then the electric field exists in a region which is 10 centimeter along the x direction. So 10 centimeter, it means it is 0.1 meter along the x direction. Then due to the electric field, the deflection of the charged particles in the y direction is due to the deflection of charge in the y direction. So along the y-axis, what is their uh, displacement? Their displacement along the y-axis, that only I have to find out. That only I have to find out. So now here y, we can say y will be equal to, since along y-axis only the acceleration is acting, acceleration along y, that is QE by m. And acceleration along x-axis is 0, so Vx, that is constant. The velocity along x-axis, that is equal to v naught only. But yeah, and so x, I can say the displacement along the x-axis, that is 0.1 meter. So that is equal to v naught into t. So t will be equal to x by v naught, and y will be equal to half into ay into t square. Since the initial velocity along the y direction is 0 only, so therefore y will be equal to half into ay acceleration, which is QE by m into t square. T is x by v naught whole square. So therefore y will be equal to half of q by m value, that is been told, q by m value 2 into 10 power 11 coulomb per kg into 1 by m. No, so it is E electric field, that is 1800 into x is 0.1 by v naught, which is v naught is 3 into 10 power 7 and its whole square. So therefore now 2 will cancel. This will be, therefore the displacement along the y-axis, that will be equal to 10 power 12 into 8, sorry, 10 power 11, 12 plus 1, 13, 10 power 13 into 18 into this is 10 power minus 1. This is 1 by 3 into 10 power minus 1 minus 7, so 10 power minus 8, its whole square. So this much meter it will come. So this will be 18 into 10 power 13 into, this is 1 by 9 into 10 power minus 16. So this much meter. So 9 to the 18. So it is 2 into 10 power minus 3 meter, or I can say 2 millimeter. So 2 millimeter is the deflection of the charged particles in the y direction. Then here it is told two identical metallic spheres A and B, when placed at certain distance, two identical metallic spheres and placed at a certain distance in air, repel each other with a force F. So their masses are m and their volume is v. So they are identical. Another identical uncharged sphere C is first placed in contact with A, and then in contact with B, and then finally placed at the midpoint in between spheres A and B. The force experienced by the sphere C will be. So they are identical, means their radius will be same only. So here we can say that when they both are having, suppose, charge q also. So therefore and suppose they are placed at uh, distance d in between them. So therefore the they will repel each other with a force F. So F will be equal to K Q1 Q2 means KQ square by D square. So now this is the F force, which is Q square by 4 pi epsilon naught into D square. And then it is C sphere, the sphere C is uncharged. So I can say that the net charge will be same after they are placed in contact. So I can say this will also have charge Q1 suppose, and this will also have charge Q1 after they are kept in contact. Since if I do KQ1 by R plus KQ1 dash by R plus KQ2 equal to KQ2 by R. So then obviously Q1 dash and Q2 will be obviously same. So let's take them as Q1 only. So it means what 2Q1 that will be equal to Q. So therefore Q1 equal to Q by 2. So it means now what will happen after they are kept in contact, the first sphere A will have charge Q by 2 on it, and the second sphere, so it is having charge Q1 and it is kept in contact with this. Placed in and then in contact with B. So now it is having charge Q by 2 and it is having Q. So now finally it will have charge Q2 and this also will have charge Q2. So therefore I can say that 2Q2, since their radiuses are same, so their potential also should be same. Since they are having same radiuses, so their final potential should be same. So I can say it will also have charge Q2, this will also have charge Q2. So 2Q2 that is equal to Q by 2 plus Q, that is 3Q by 2. So therefore Q2 will be equal to 3Q by 4. So Q2, this is having 3Q by 4 and this one is also having charge 3Q by 4 now. Now it is placed at the midpoint of the spheres A and B. So now C is placed at the midpoint and it is kept at x equal to d by 2 meter and it is having charge 3Q by 4, having charge 3Q by 4. And then this one, it is having charge Q1, which is equal to Q by 2 at x equal to 0. And here x equal to d, the charge Q2, which is 3Q by 4, that is kept. B, this is C, this is A. Okay. So now it is asked the force experienced by sphere C will be. So here it will experience repulsion due to A, force on C due to A, and here it will be force on C due to B. So FCA, the force on C due to A, that will be equal to K Q2 into K Q1 Q2 by R squares. This R, it is D by 2, since why C is placed at the midpoint only. C is placed at the midpoint in between sphere C and B. So FCA, that will be equal to K Q2. So this is also Q2. So FCA, that is force on C due to A. So it will be K Q1 into Q2 by R square. So D by 2 whole square, and then force on C due to B, that will be equal to K into Q2 into Q2, K Q2 square by D by 2 whole square. So therefore the net force, so now this will be equal to 4k into, okay, 4 into q1. Q1 is q by 2. So this is 1 by 4 pi epsilon naught into 4 by d square into this will be equal to q1 q2. Q1 is a q by 2 and q2 that is 3q by 4. So therefore now 4 and 4 will cancel. So this will be to 3q square by 4 to the 8 pi epsilon naught d square. Then this will be equal to k, which is 1 by 4 pi epsilon naught into then q2 square. Q2 is 3q by 4 whole square into 4 by d square. 4 will cancel. So now this will be 9q square by 16 pi epsilon naught d square. Now obviously this I can write 2 3 are 6, 6 by 16 q square by pi epsilon naught d square. So now therefore here you can see the magnitude of FCB that is more than FCA. So therefore the net force that will be net force acting on the sphere C. So that will be equal to FCB, which is 9q square by 16 pi epsilon naught d square, then minus 6q square by 16 pi epsilon naught d square. So which will be equal to 3q square by 9 minus 6 is 3q square by 16 pi epsilon naught d square. So this is the net force which is acting. Now q square by 4 pi epsilon naught d square, that is F. So this I can write 3 by 4 into q square by 4 pi epsilon naught d square. So it is 3F by 4. So the new force is equal to 3F by 4. So option B is the correct answer. Then here it is told a spherically symmetrical charge uh, distribution is considered with charge density varying as rho as a function of r, which is rho naught into 3 by 4. So here the spherically symmetrical charge distribution is considered with charge density varying as rho r as a function of r. So it is rho naught into 3 by 4 minus r by r for r less than or equal to r, or r less than or equal to r. So now therefore where r is the small r is the distance from the center of the electric field at a point P will be. So electric field at any point P, which is at a radius which is at a distance r from the center for obviously r less than or equal to r, the electric field that will be equal to kq by r square. Kq by r square. Now q, that how to find? Q will be equal to integral rho dv. Now dv that is equal to so dv is the small volume element. So this dv that will be equal to 4, which is equal to 4 pi r square dr. Therefore this is q by 4 pi epsilon naught d square, 4 pi epsilon naught r square. So now therefore q that will be equal to rho integral. So r is going from 0 to r, suppose, and this is actually so till here there is how much charge net that we have to find out. So therefore q equal to integral 0 to r rho, that is rho naught into 3 by 4 minus r by r to dv, that is rho naught into 3 by 4 minus r by r to dv, that is 4 pi r square dr. Now this part is constant, so it will be rho naught into 3 pi, 4 will cancel, rho naught 3 pi integral r square dr from 0 to r, then minus this is 4 pi rho naught 4 pi rho naught by r into r cube dr from 0 to r. So this is q. So therefore q, that will be equal to, so this is 3 pi rho naught into integral r square dr, that is r cube by 3, minus this is 4 pi rho naught by r to r power 4 by 4. So now, therefore the electric field at the point r, that is equal to q by 4 pi epsilon naught r square, so which will be equal to 1 by 4 pi epsilon naught r square into 3 pi rho naught by 3 into r cube minus 4 pi rho naught r power 4 by 4r. Now 4 will cancel, 3 will cancel, then pi will also cancel, and this will be equal to 1 by 4 epsilon naught r square, 1 by 4 epsilon naught r square into, from here also r square I can take as common, so this is equal to, and rho naught also I can take as common, so this is r minus r square rho naught, so this is r square by r square will cancel, so then from here r, if I take as common outside, so this will be rho naught r by 4 epsilon naught into 1 minus r by r, rho r by 4 epsilon naught to 1 minus r by r. So option C is the correct answer. Then it is told the given below are two statements. Statement 1 is electric potential is constant within and at the surface of each conductor. Electric potential is constant. V is constant within and at the surface of each conductor. V is constant on the surface, which is V is kq by r on the surface also, and inside also. Since y inside electric field is 0, so we know that conductor is an equipotential body. Conductor is always equipotential. It means at all points on its surface and inside the potential will be same at all points. Then electric field just outside a charged conductor is perpendicular to the surface of the conductor. Electric field outside the surface of a charged conductor is perpendicular to the surface of the conductor at every point. Yeah, so it is true also, since why the electric field, if that is not perpendicular to the surface, then some component would be there, which is component of the electric field will be along the surface, and hence we know that in the direction of the electric field the uh, uh, potential decreases, the electric potential decreases. So now, since the e- so if some component of the electric field is along the surface of the charged conductor, it means that the po- potential at every point will not be the same. So which will not satisfy the required condition of any conductor. Since at every point in a conductor, the potential should be the same. Uh, electric potential. Okay, so here uh, both the statements 1 and 2 are correct. So option A is the correct answer. And here it is told a uniform electric field E, which is equal to 8 m by E volt per meter. Uniform electric field E, which is equal to 8 m by E volt per meter, is created between two parallel plates of length 1 meter as shown in figure, where m is the mass of the electron, m is the mass of the electron, and E is the charge of the electron, and Q is E is the charge of the electron. Then it is told an electron enters the field symmetrically in between the plates with a speed u, which is 2 meter per second. The angle of deviation theta of the path of the electron as it comes out of the field will be. So here obviously some electric field is acting, and the electric field that is equal to 8 m by E. So this is the electron. So therefore the force, the e- e- electrostatic force acting on the electron, which will be equal to E into E. So therefore the acceleration of the electron is acting only along y-axis. So now here the acceleration is acting only along the y-axis, and along x-axis there is no acceleration. So therefore the velocity along x-axis will be constant only, which is v cos theta, which is equal to u, and v sin theta, which is the y component of the electric field, y component of the velocity. So that will be equal to ay into t. Ay, the acceleration along the y component, that is the electrostatic force by mass. So that is equal to E by m. So that is E by m into 8 m by E, which is 8 meter per second square. So the acceleration along the y component is 8 meter per second square. So therefore the velocity, the y component of the velocity, which is 8 into t meter per second. So now where t, how to find? So t will be equal to L by u, where L is the length of the each of the plates, which is 1 meter. So t is equal to 1 by u. U is 2, so it is half second. T is half second. So therefore it is 8 into 1 by 2, that is 4 meter per second. And Vx, that will be equal to u, that is 2 meter per second. So now uh, therefore we can say tan theta, which is v sin theta by v cos theta, is equal to Vy by Vx. So Vy is 4 and Vx is 2. So 2 to the 4. So tan theta equals to 2. So theta equals to tan inverse of 2. So tan inverse of 2 is the required angle of deviation of the path of the electron as it comes out of the field. So tan inverse 2. So option B is the correct answer. Then here it is told a charge of 4 microcoulomb is to be uh, d- divided into 2. A charge of 4 microcoulomb is to be divided into 2. The distance between the two divided charges is constant, the magnitude of the divided charges so that the force between them is maximum will be. So let's suppose they are kept at a distance x in between them. Mm, or we can say they are kept at uh, uh, distance L in between them, distance L in between them. So here we will have charge q microcoulomb, and here we will have suppose 4 minus q microcoulomb. Since why? Since here it is told 4 coulomb, 4 microcoulomb should be divided into 2. 4 microcoulomb should be divided into two parts. Then the magnitude of the divided charges so that the force in between them is maximum. So the force which is the repulsive force acting in between them, that should be maximized. So F will be equal to KQ into 4 minus Q, KQ1 Q2 by L square. So L is kept constant. So here it is told, so F is a function of Q, which I can say Q into 4 minus Q by 4 pi epsilon naught into L square. So now for maximum force, we can say that for the force, if I have to maximize it, then F will be F as a function of Q it will be. So for maximizing this force, so that will be equal to dF by dQ, that should be equal to 0. So therefore d by dq of q into 4 minus q by 4 pi epsilon naught into L square, that should be equal to 0. So therefore d by dq of 4q minus q square, that should be equal to 0. So therefore 4 minus 2q, that should be equal to 0. So it means q should be equal to 4 by 2, that is 2. Okay, so it means each the charges should be equally divided into 2 microcoulomb and 2 microcoulomb. So option B is the correct answer. And here it is told two identical positive charges Q are which each are fixed at a distance. Two identical positive charges Q each are fixed at uh, a distance of 2a apart from each other. Another point charge Q naught with mass m is placed at the midpoint in between the two fixed charges. So it is placed at, we can say, at x equal to a, and the this charge is placed at x equal to 0, and this charge is placed at x equal to 2a. So it is kept, this q naught is kept at the midpoint in between the two fixed charges. For a small displacement along the line joining the fixed charges, the charge q naught executes SHM. So if we slightly displace it by a length x, then it will oscillate to and fro. So it will perform SHM, and then the time period of oscillation of the charge q naught will be, the time period of oscillation of the charge q naught will be. So if it is displaced by a length, small length x, then I can say here it is at suppose this we take, this is the y-axis, so it is at y equal to 0, this is y equal to a, this is y equal to 2a, so this is y equal to a plus x, so this length is a minus x, this length is a plus x. So therefore the net force acting will be towards the left. So the net force acting, that is f1 minus f2, which is k q1 q2 k q naught q by q2 by a square a minus x whole square minus th this way force will act, and this way also this force will act, which is k q naught q by a plus x whole square. So this is equal to k, so it is q naught q by 4 pi epsilon naught into, this is 1 by a minus x whole square minus 1 by a plus x whole square. So therefore the net force that is acting, that is equal to, and here we can also use this fact that x is much less than a. And this approximation can be used here, since why since here it is told there is a small displacement along the line joining the fixed charges. So x is very small with respect to a. So the net force that will be equal to q naught q by 4 pi epsilon naught into 4 pi epsilon naught, and this will be equal to this, it will be equal to a minus x into a plus x whole square, and this will be equal to a plus x whole square minus of a minus x whole square. So this will be equal to q naught q by 4 pi epsilon naught into this will be equal to a plus b whole square minus of a minus b whole square. So it will be equal to 4ax divided by uh, a square minus x square whole square. So therefore the time period of oscillation that we have to find out. So here a square minus x square, I can write it is approximately equal to a square only, since x is much less than a. So therefore the net force that is approximately, which is 4 will cancel. So I can say this is q naught q a x by pi epsilon naught into a power 4, which is a power 4. So a cube will come. So it is q naught q x q naught q by pi epsilon naught a cube into x. So therefore we know that now F net is mass into acceleration, So mass into acceleration, we can take it as a dash, which is equal to q naught q by pi epsilon naught a cube into x. So therefore acceleration, that is q naught q by pi m epsilon naught a cube into x, which is equal to omega naught omega square x. So therefore the time period, therefore that o o omega square that is equal to q naught q by pi m epsilon naught a cube. So therefore the time period has been asked. So now therefore we can say 2 pi by t, which is omega. Omega will be square root of this, which is q naught q by pi m epsilon naught a cube. So therefore t will be equal to 2 pi into root over pi m epsilon naught a cube by q naught q. 2 pi, or if you take it inside, then we will have, this is 4 pi square. So t will be equal to root over 4 pi cube m epsilon naught a cube by q naught cube. 4 pi cube epsilon naught m a cube. We can say 4 pi cube epsilon naught m a cube by q naught cube. Not m a cube by q naught cube. So option A is the correct answer.